Hi, my name is Abdulaziz, and my paper is titled Anticipatory Bias Correction in Machine Learning Applications. This is a joint work with my colleague Chidansh and my advisors, David and Vivek. One of the problems that is really associated to the fairness aspect is the distribution shift problem. Let's take an example. Let's assume that we have a distribution P, and from this distribution P, we sample based on the IID assumption to a training and testing subsets. So for example, we have an equal represented individuals from different groups, for example, the blue and the red group for both the training and testing subsets. But usually this IID assumption is usually violated in practice. We might have a small subset, for example, the green group that our model has not seen before. And if we use our model that has been trained on the training and testing, we assume that the model will not perform well for the green group, not only for accuracy, but also for the fairness as well. In this scenario, we call this problem a distribution shift. Another type of distribution shift is the temporal shift. So let's assume that we have a time dimension, and we assume that the distribution is evolving in the aspect of the time step. So for example, we have a temporally evolving distributions. So maybe at time T1, we have the same scenario. We have the individuals from different groups, but they are equally represented. And maybe at time T2, we could see that the red group is somehow shrinking, maybe to different causes that we have not been aware of. Maybe at time T, we could see that the red group is significantly shrinking. And these causes, it might be related to the machine learning models, or maybe it's related to the nature, or maybe unknown factors. One of these, in the first cause, for example, the machine learning model is directly or indirectly affect the society, and that will lead to a feedback loop. And this is usually observed in different machine learning applications. For example, the credit application scenario, or maybe the predictive policing models, and also for the language model. Usually these three different applications, they suffer from this problem, which is basically the model predictions will affect certain groups, and then in the next cycle, this certain group will less likely to be observed in the distribution. The second cause is the society is changing by itself. For example, the crime behaviors, the ratio of females and females who are applying to colleges, as we have seen recently, that the females applicants are more likely to apply for colleges compared to the males students. So in this work, we wanted to show that the bias fluctuates frequently and is rarely stable. And also we want to address the idea of the limitation of static learning. And we think that the static learning is more likely not to perform well for both accuracy and fairness. And the second aspect, we propose a framework for the bias anticipation that could help us to mitigate bias before it happens. And this is the main contribution in this paper. We wanted to emphasize on this aspect, that we wanted to mitigate the bias before we see it. And lastly, we propose a newer metrics for quantifying bias in the temporally evolving settings. Thank you for listening. I hope you enjoy the presentation.